There is another situation where a static route might be useful. Let me demonstrate another network. Here, the headquarters router is connected to the ISP. There are many networks on the internet. So, do we require all of those networks on the internet in our routing table? Because we can use a default route. Let me show you what it is. First, we will configure an IP address on the fast Ethernet 10 of the headquarters router. Now, we will check our connectivity from the headquarters router to the ISP router. A quick ping to the ISP router proves that we can reach the ISP. As you see, the ping is working to the ISP router. Now, let's look at our routing table. Right now, the headquarters router only knows how to reach network 1.1.1.0 because it's directly connected. Now, I will configure our headquarters router to use local DNS servers, or you can use any other public DNS servers, just to inform our router to use these DNS servers for name resolving. So, I say IP name server 8.8.8.8 8.8.4.4. Now, I will ping www.yahoo.com. It doesn't work. Configuring the DNS servers on our router wouldn't get us the connection to the internet. It's just for name resolving. And it wouldn't resolve as long as it can connect to these public DNS servers on the internet. So let's configure a default route so that we can reach the internet. IP route 0.0.0.0, 0.0.0.0, 1.1.1.1. Let me explain this one. The first zeros is the network address. In this case, it means all networks. The second zeros is the subnet mask. All zeros means all subnet masks. 1.1.1.1 is the next hop IP address. In this case, the IP address of the ISP router. In other words, this static route will match all networks, and that's why we call it a default route. When our router doesn't know where to deliver IP packets to, we will throw it over to the ISP and it will be their job to deliver it. Let's now test our internet connectivity. Ping www.yahoo.com. This time is working, as you see. I'd like to thank you for viewing. See you next video.